So in this video, we're going to continue with the study of trigonometry and discuss the cosine rule. So the cosine rule, unlike the trig ratios sine, cos, and tan for the right angle triangles, the cosine rule works with any triangle, including right angle triangles too. So let's draw a triangle. Now, I am no Picasso, it's the math that's of the essence over here in these videos. So, same convention with the labeling of the triangle from the sine rule in the previous video. You could take a look at that if you haven't seen it. It's labeled conventionally. It could be any variables, but most textbook will have it like this. So side A, side B, side C. It doesn't matter what is A, B, or C. Now, the angle opposite B, it's called the opposite interior angle. We could just say the angle opposite B to make it simple. The angle opposite to C, or the angle opposite interior to C, and the angle opposite interior, or the angle opposite B, labeled as such. Now, the cosine rule, it have three formulas for the cosine rule, but with some clever looking at the formulae and clever deductions, you could generalize what the cosine rule says in a statement, which is what we're going to do here. So the first form of the cosine rule says this. So for side A, we have the sum of the other two sides squared minus 2 times the product of the two sides, other two sides, cosine of the angle A. Now for side B, think about it as three forms of the formula where the formula is expressed as such, where a length of the triangle is a subject. So for B, we will have A squared plus C squared minus 2. Okay, that looking like a Z. When we get to complex numbers, we gonna see how I write Z's. So 2 AC cosine B. And for C now is A squared plus B squared minus 2AB cosine of C. These are the cosine rules, but let's generalize this here so we can see statement. For side X of a triangle, I use X to mean to generalize it then, like we talking about any of the sides here. When I say side X of a triangle, the no, I'm gonna put for side X of a triangle, this is actually squared, my bad. Tell all you, I'd be doing these videos from my head, and sometime I would make mistakes and point out my mistakes rather than do a video again that seemed to be perfect, because sometimes you learn by mistakes. So yeah, so for side x of a triangle, the that's why I was sticking this with the statement, because something wasn't right here. For side x of a triangle, the cosine rule says square side x and equate it to the sum of the squares of the other two sides and minus the product of two multiplied, let me just put multiplied, 2 multiplied by the other two sides multiplied again by the cosine of the side x, meaning the side that was originally in question. So like if you pause this video and you could deduce my fun, because my students just give me so much trash talk from my handwriting, but again it's the essence of the math. And you look at this, this is a statement to remember these three formulas. So if you could like commit this to memory, you don't have to memorize this. But like one cool thing about the cosine rule to point out, like if you squint hard enough, like I just highlighted it for this part here, but it holds true for this one and this one here. Does that not kind of look Pythagorean-ish? So there is a connection with the cosine rule and the Pythagorean theorem, which would be discussed in higher level mathematical videos, not at this level, which would be in our timing. So these are the cosine rules. This is a statement to generalize these three formulas. So let's look at an example. Already on 8 minutes. Let's try to piece in this. Okay. So given, I know most of the triangles I draw is just be like this, but it could be any triangle. It's just laziness on my part. But efficiency and consistency throughout the examples explaining. So a myriad of reasons. So let me say we have, here's 30, here is 15 meters, here's 17 meters. Obviously just not drawn to scale, it's a sketch. Let's say I want to find this side. Let's call this Z. So I purposely choose another variable besides the, let me restate that. I purposely choose a next variable to represent the length, just to see if you all understood the generalizing of the statement that I give that generalizes the cosine rule. So if we want to find z, we square z, square the other two sides and sum them, minus 2, the product of the other two sides, cosine of the opposite interior angle of z, or the angle opposite to t. Now there's one more step. It says z is equals to root, because it's z squared, we want to find z. 15 squared plus 17 squared minus 2 by 15 by 17 by cosine to t. Now plug this in your calculator and you will get the answer. So you could use the cosine rule in the next way to find the angle. But like, so far, this should be sufficient. I mean, let me do an example with the one with the angle. Let's see, we have a triangle. Oh, that's supposed to be straight, but a freehandedness on the tablet. Here's 30, here's 15, here's 20. So using the cosine rule, we could actually find any one of these angles. So let's say I want to find this angle F. So we have to look at the side that is opposite the angle, or the opposite exterior length in proper mathematical terms, which is 20, square it, square the other two sides, sum them, minus 2, the product of the other two sides, cosine of your angle you're trying to find. Now we have to do some rearranging, so you would get, wait, I don't think this, I think I have to put here as 40, just to be safe, to make sure it works out. Nah, I'm gonna put a bigger number there just to be safe, because like running the math, even though like I'm not using a calculator, like I know from years of practice, like whether or not, like if I make up a question, which I do, if it would work out or not. So let's say here is 40. No, to be safe, 50. Okay, so I'm gonna keep the same color. 50. So we have 50 squared. 50 squared, yeah, just to be safe. So we do some rearranging, so we say 50 squared minus 30 squared minus 15 squared is equals to minus 2 by 15 by 30 cosine F. So we have to isolate cosine F, so I'm running out of space, so let me just draw some sort of separation. So I'm taking this working over here and continuing it to all here. So isolating cosine f, we have 50 squared minus 30 squared minus 15 squared all over minus 2 by 15 by 30 is equals the cosine f. So it's just basically making f the subject of the formula. So now we would say f is equals to the cosine inverse of whatever number this thing here when you're plugging in a calculator give you. So let me just call this thing on the left hand side of this equation what's a random letter G. So plug this in a calculator, you'll get a number, and then the last step is to take the cos inverse of that number G. That's it for the cosine rule.